Hello students, welcome to my channel The Physics Guru. Today we discuss a question of projectile motion in which the final velocity becomes perpendicular to the initial velocity. Let us see the question and the diagram. Here is the figure. See, this particle is given a velocity u, initial velocity u, making an angle theta with the horizontal from the point A on the ground. Then this particle will follow this path along the parabola and land here. Question is, a particle is thrown with initial velocity u from the ground, making an angle theta with the horizontal. Find the time after which the velocity vector becomes perpendicular to the initial velocity. That means, as the particle moves along this path, where do you think that velocity vector will become perpendicular to this initial velocity? Let us see. Now, let us take this point here. You know, wherever the particle will move along the parabolic path, the velocity vector will be always tangential to the curve path. Here is a very important concept, that instantaneous velocity vector is always along the tangential direction or trajectory. This theorem is true not only for the projectile motion of parabolic path, but it is also true for straight line motion or for circular motion also, or any kind of path. The instantaneous velocity vector will always be along the tangential direction. As you can see here at the initial point also, the velocity vector is tangent to the path. Here also it is tangent to the path. So what we want is that, see, if we draw a line along the direction of the tangent to this final velocity v at this point, and draw another tangent along the initial velocity vector, then this initial velocity vector and final velocity vector, we are supposed to make them perpendicular. That means at this point these two tangents must intersect perpendicularly at 90 degrees. This is what we require in this question, that after how much time this particle velocity vector will make 90 degree angle with the initial velocity vector. As you can see in this figure, by drawing these dotted lines which is along a tangent to the paths, we can see that this velocity vector somewhere here before landing, somewhere here, the direction of the velocity vector along the tangent is actually perpendicular to the initial velocity vector. So we need to know how much is this time taken. As you know, total time taken is 2u sin theta by g, but of course this answer should be less than that quantity. It is somewhere between the highest point and between the landing point. So let's proceed to solve this question. First of all, what we will do, that we will make the components of the initial velocity vector. As the initial velocity vector is making angle theta with the horizontal component will be u cos theta and the vertical component will be u sin theta. Here it should be remembered that whichever component makes angle theta with the vector will be the cosine component. That is the way we decide which one will be cos component, which will be sine component. So whichever component makes angle theta with the vector will be cosine component, and the one which makes 90 minus theta will be sine component. So we have made the initial and final velocity components of the velocity at the initial point. Then same we will do at the final point also. Here you see, here this velocity vector can be resolved into this horizontal component and vertical component. Okay, but we do not know that this angle or this angle, which of these is angle theta, or maybe some other angle. What could be this value of these angles here? How much angle does this velocity vector v make with the horizontal or with the vertical? How we will calculate? So look at this. Point A, C and this point over here B makes a right triangle. Observe this right triangle ABC carefully, which is right angle at C, the triangle ACB. In this triangle, angle C is 90 degree, angle A is theta. So angle B, this remaining angle here must be 90 minus theta, because you know the total angles, internal angles sum must be equal to 180 degree. So 90 plus 91 is theta, and plus theta if we add, of course you are getting 180. So this angle B is 90 minus theta. Now we are supposed to find out this angle. Okay, we want to know this angle. So for that purpose, let us extend this vertical line down. Draw a perpendicular along the vertical component till here, perpendicular, and let us say we call this point as E and this point you call it D, so that we have a triangle. Once again we have a right triangle DBE. DBE is the right triangle which is right angled at E. Now once again you see in this triangle DEB, the angle E is 90 degree, angle B is 90 minus theta, so this angle must be equal to theta. Thus we see in this right triangle also we got the angle theta. Since we now know the angle theta, can we say that this velocity vector, this component of the vector must be cos component, because as I said here, whichever component makes the angle theta with the vector will be cosine component. So same thing rule applies here, and this vertical component will become v cos theta, and here this will be v sin theta. Okay, so we have got the components of velocity at initial place and also at this final place. Now we are supposed to find out how much time does it take for the particle to go from A to D. Fine. So let us apply some concepts of the projectile motion. First of all, look at this horizontal component of velocity at the initial point u cos theta, and look at this horizontal component of velocity at the final point v sin theta. What relation can we say between these two velocities? The concept is that the horizontal component of velocity remains constant. So the horizontal component of velocity at the starting point, which is u cos theta, and the horizontal component of velocity at the point D, which is v sin theta, must be equal. So we write down that v sin theta is equal to u cos theta. Very well. So from here we can find out the value of v. Thus we came to know what is the magnitude of this velocity v at this instant when it makes 90 degree angle with the initial velocity. So this velocity v is u cos theta divided by sin theta. Let us keep it as our one of the equations. Next we want to find out how much time is taken from here to here. Now what we'll do that, for the vertical motion we can apply the first equation of motion v is equal to u plus at only for y components. As you can see, this vy is equal to uy plus ayt is nothing but the first equation of motion, but the components, this is vy is the y component of final velocity, this one, uy is the y component of initial velocity, which is this one, and ay is the y component of acceleration. Let us substitute the values. See, here is the vy, y component of final velocity, which is v cos theta in the downward direction, so therefore minus v cos theta, equal to uy, which is the y component of initial velocity, which is upward direction, positive value u sin theta, and acceleration along the y direction. As you know, for any projectile motion the acceleration is always in the vertically downward direction. That's why minus g is the acceleration of the particle, so minus g into t. So this t is the time taken for this particle to travel from the point A to D, after which the final velocity vector makes 90 degree angle with the initial velocity vector. We are supposed to find out the value of t. Let us find out. So for solving this equation, set this minus gt on the left side and bring this minus v cos theta on the right side. So we'll get this gt goes to this side, become gt, and u sin theta, and this minus v cos theta come to this side, become plus v cos theta. In the next step we will substitute this value v in this place v. So on the previous page we obtained this equation gt is equal to u sin theta plus v cos theta, and we already know the value v, which is u cos theta by sin theta. We calculated on the previous page. Substitute this value here and we will get u sin theta plus, in place of v, u cos theta by sin theta into cos theta. Now this cos theta and cos theta will get multiplied and we will get cos squared theta in the next step. Now we have to add both these fractions. So by cross multiplication method, u sin theta into sin theta becomes sin squared theta and plus u cos squared theta, the whole thing divided by sin theta. Now in this numerator, as you can see, u is common factor, so we will take u common and we get in the bracket sin squared theta plus cos squared theta. It's a well-known identity that sin squared theta plus cos squared theta is equal to 1. So u into 1 upon sin theta. So gt is equal to u by sin theta. Therefore you can bring this g below this denominator and we'll get the value t. T is equal to u divided by g sin theta. Hence the problem is solved. The time taken for particle to go from A to D is u divided by g sine theta. Thank you for watching my video. Please like and subscribe. Thank you.